110. This is lab number 8. We're going to talk about a rational function. We're going to talk about finding the domain, the x-intercepts, and the vertical asymptotes for a rational function. All right, so keys to finding the all of those things would be first starting by finding the domain or factoring the entire problem. So those go step by step, hand in hand. So to find the domain, we're going to take the denominator. Before we simplify, if it will simplify, uh, or anything, we're going to take the denominator, x squared minus 8x plus 12 for this particular problem, and we're going to set it equal to 0. We're going to use factoring to try to find the domain, the x values that won't work for this problem. So x method, multiply to be 12, add to be -8, be -6, and -2. Because there's a 1 in front of x squared, we can go x minus 6, x minus 2, and set each of those equal to 0. We know x cannot be 6 and x cannot be 2 out of that. So that helps us in the denominator have the factored form x minus 6 and x minus 2. Okay, we need to factor the numerator in order to find out if there's any cancellation happening. So the domain for this problem we would list that as x, all x's, as long as x does not equal 6 or 2. I'm going to write 2 first, numerical order. All right, so there's the domain for that problem. Let's factor the numerator, and I'll do that right here. 2x squared minus 5x minus 3. I'm going to use the x method factoring that. Multiply 2 times -3 to get -6, and add to be -5. -6 times 1 will be 2x squared minus 6x plus 1x minus 3. I'm going to group that together. 2x, x minus 3 plus 1, x minus 3. So the factored form of the numerator is 2x plus 1 and then x minus 3. And factoring there did not afford us a cancellation with any of our factors, top and bottom. So that means that our vertical asymptotes are going to come from both of these factors in the denominator. Okay, if one of the factors would have canceled, the simplified version is what you pull your vertical asymptotes from. But because neither of these simplified, these factors, x equals 6 and x equals 2, are your two vertical asymptotes for the graph of this polynomial, or rational function, excuse me. To find the x-intercepts, we want to take the numerator and set that equal to 0, which is the factored form. Is nice to be able to do that with. We have 2x plus 1, parentheses, and x minus 3, parentheses. We would set each of those equal to 0 and solve each of those. So we're going to move the 1 by subtraction and divide by 2, so that's -1/2. Add the 3, so that's x equals 3. So we get x-intercepts at -1/2, 0, and 3, 0 are the x-intercepts for the numerator or the actual rational function. If we looked at the graph of this rational function, clear out this other stuff. And to do that, you need to put the numerator in parentheses. So I'm going to put the original problem, 2x squared minus 5x minus 3. Close the parentheses, divided by, open up another set of parentheses, x squared minus 8x plus 12. Graph. And we see this polynomial crossing the x-axis. There is the -1/2 right there. We see it crossing at +3. And then we see what would be an imaginary vertical asymptote that's there. And I'll copy and paste this to my notes. so that we can draw that in there. So draw in there. All right, so there would be a vertical asymptote right here. That's the 2, and 3, 4, 5, 6. It'd be right here. And we see how that shows the curvature of that graph using those vertical asymptotes. And here, there's our x-intercepts, those dots right there. So we see those things that we're finding along with the graph of this rational function. And that's lab number 8 for Math 110.